Hi everyone, welcome to a very special event that we have here today. My name's Brett Drummond. I'm one of the co-founders of MStranslate, and you can see that I'm joined here today by Jon Strum, who is the host of RealTalk MS. And if you're one of our regular followers to either platform, you know that we're both passionate about bringing high quality research to the multiple sclerosis community in a way that they can easily understand. And with that in mind, we are both incredibly excited today to be joined by Professor Rhonda Voskuhl from UCLA. Now, to give you an idea as to why we're so excited about this, recently the NIH, which is one of the research funding bodies in the United States of America, announced a requirement that all studies include both males and females in their grant applications. And one of their reasons for this was referencing Rhonda's work, which she's been pursuing for over 25 years since her work as a postdoc fellow, into sex differences in multiple sclerosis and other diseases. So we're incredibly excited. Jon, I'll throw over to you to talk as well about your interest in this work and then get us started.
Well, thanks very much, Brett. It's great to be with you in this trailblazing effort, joint effort of ours. And Dr. Voskuhl, I appreciate you being a part of it. You know, one of the first things that someone learns after being diagnosed with MS is that more women, almost 3 times more women than men, are diagnosed with MS. And I think that when we first hear that statistic, we sort of file it away under, well, that's just the way things are. But this far from insignificant fact is something that not only affects who is diagnosed with MS, but also how MS might progress across a person's lifetime. So understanding the impact of sex differences in MS is important. Before we get into some of your recent research, Dr. Voskuhl, can you tell us how you first became interested in exploring how and why MS affects men and women differently?
Yes, so I am aligned with your thinking, and that is when I was a postdoc actually at the NIH back in the 90s, it was well known that females were more susceptible to MS. We saw patients and they tended to be, more often than not females as compared to males, like you said, about 3 to 1. And so I thought that was extremely interesting, and I thought it should be actually investigated, and particularly when I started to do investigations that involved the mouse model of MS, and the mouse model that is, there are several, but the one that is very inflammatory and relapsing, that particular model, my mentor said, well, just order female mice. And I said, why? And they said, well, because they're more likely to get the disease, so we can study what we want to study. And I said, well, that's interesting. So now we have the mouse model that's this particular model, which is a certain strain that is inflammatory. It's showing the same thing that we're seeing in patients. And I said, I think that would be interesting so I went ahead and ordered both, females and males. And I tried to figure it out because I think if you could figure out why females are more susceptible, and I knew that it wouldn't be just societal things or environmental things. While they can play a role, there had to be something very basic in the biology of either sex hormones or sex chromosomes, since it was even happening in these mice in a cage where they didn't have differences in all these societal pressures. And so that's what got me really interested in it. I wanted to figure out something that was very widely accepted and I think, overwhelmingly obvious.
Okay, and we're going to talk about some fascinating work that you presented at ACTRIMS recently, but before we get onto that and following on from, I guess, Jon's point there, a lot of people in the MS community sort of think when we think about sex differences that if I have already developed MS, if I've already been diagnosed, that this doesn't apply to me necessarily anymore. But, why is your research particularly important for people living with MS? Because it does go well beyond that step.
Well, because the thing is, we should not be ignoring things, these naturally occurring observations that are so prominent, because they can lead to incredibly valuable clues as disease modifiers to reverse some of the things that we observe. For example, not only is there a sex difference in MS with 3 to 1 females than males, the incidence of that first episode can be a lot like the clinically isolated syndrome, which is the first relapsing phase. So the susceptibility can be highly related to this inflammatory phase, and with females being more susceptible than males. And then the other element to this is that there are actually two sex differences. And the other one is that when men get MS, which is less likely, but when they do, they actually have worse progression. So they have worse disability accumulation. So in that sense, you can see how the study of sex differences, actually two, females being more susceptible to this inflammatory onset, as well as males having worse disability progression. Finding the mechanisms for those two and trying to reverse them can help both the early phase of disease with inflammation as well as the late phase of disease with disability progression. And it's relevant to both females and males.
Well, you know, speaking about the later phases of the disease at the recent ACTRIMS Forum, you delivered a presentation about your research into the effects of menopause on MS. What are you learning from that work?
Exactly. So this was indeed focusing on that later stage when people are around in their 50s, not when they're in their 20s, 25, 30. And the point of studying this was that, well, a lot of women do have MS. And the good news is they don't die early of MS. They live a long and full life, and that means they are going to go through menopause. And so what's a striking gap in our information is what happens to women when they go through menopause and they have MS. What happens to their MS when they go through menopause? And this is a striking lack of knowledge. So what I discussed was that there can actually be sex differences in this progression if you think about it like this. So the view is, or the hypothesis is, and there's a lot of data showing that both estrogen and testosterone can be neuroprotective. That means that they can slow down this disability progression that's happening in the later aging phases of the disease. And that said, both andropause would be bad for men, testosterone loss, and menopause would be bad for women. And there's a lot of data in the MS community showing that low testosterone can be bad. We've done studies, other work, people have done studies, and the idea would be perhaps low estrogen could also be bad. Now you could actually have a sex difference if you think about it, because with men, andropause occurs, testosterone drops by 1 to 2% at the age of 30 to the age of 70. It's a very low, long process, very slow process in men, but in women, estrogen drops abruptly at the age of 50. Now, why is that important? Because you can see there could be a sex difference at the ages around 30 to 50, whereby men are losing that protection, and women actually aren't because they haven't had menopause yet. And that's probably why we hypothesize why men do worse. And we've actually shown this in a recent paper too, that men have worse brain atrophy in particular regions, especially when they were at that age of 35 to 50. Now, the big question is, what happens to women? When theirs drops? Well, that happens after age 50 in this menopausal group. So man, it drops like a bomb, and it's just all of a sudden, and it's fast. And goodness, we need to know what happens to women with their disabilities and their brain atrophy when menopause hits women with MS at the age of 50 to 55, and we just don't know what happens. There are data, I will say, out of a couple groups showing that menopause does seem to be worse for MS women in the sense that this EDSS score that many people have heard of has been reported to be worse. There's been some evidence that there's worse brain atrophy. We also know in healthy women that menopause is not good in the sense that menopausal healthy women have what's called brain fog. It's cognitive dysfunction in certain very well-defined domains such as verbal memory, processing speed. It's been well mapped out by neuropsychologists. And also other groups have shown that menopause, even in healthy women, is bad for brain atrophy in very localized regions. It's not whole cognitive problems, and it's not whole brain atrophy. We're talking about specific cognitive problems and specific localized regions of atrophy in the brain associated with menopause, even in healthy women. So we really need to understand more about menopause and how it affects MS women and try to find something to reverse this abrupt drop.
As you were explaining what happens post-menopause in terms of brain atrophy, disability, things like that, it occurred to me that the other thing that happens as women and men reach the age around 60-ish is often their neurologist recommends taking them off of disease-modifying therapy, which sounds like everything you've just said would sort of be a counter indication for doing something like that.
So that's a very important point, and I do want to say though that it's complicated, and I don't necessarily agree with it. I'll tell you what it depends on. It depends on what that disease-modifying therapy is doing. So if we do know that the natural history of MS is to go from a very inflammatory disease in these early ages, 20 to 30, to a more neurodegenerative disease in these ages 50 to 60. And so if the disease-modifying therapy is merely reducing the inflammation, it's targeting the immune system only, and it's reducing relapses, well, it might be okay. That's why they want to maybe take it away, because during that later phase, it's not characterized by relapses, and it's not characterized by lots of inflammation. The converse is it's become a neurodegenerative disease. And so, if unfortunately we don't have a drug that is neuroprotective directly, that targets CNS cells, meaning oligodendrocytes, astrocytes, microglia, these sort of cells in the brain. We don't have treatments that would be neuroprotective. I would say you would definitely not want to stop those in that later aging phase, because that's exactly what you need. And we need to develop them for that. We don't have great treatments for that progressive later phase that are not merely targeting the immune cells, let's put it that way. So it's kind of like apples and oranges. What we really need, the big holy grail, is to find things that are directly neuroprotective, focused on that neurodegenerative aspect. Because when you get older, those anti-inflammatories, purely anti-inflammatories, may not do you much good. And that's why they're stopping them.
Yeah, I mean, I think this research is incredibly interesting. And I think what will be particularly interesting to our community is, well, one, it will be hugely surprising to them that they haven't heard about this before. I think this is something that we're not talking about as much, considering, as Jon said right at the start, we know that there are these sex differences that exist, yet, as you say, there is still so much that we don't know. So I'm sure that the followers of both pages are going to be very interested, and I encourage people to maybe share some of their own anecdotal evidence, both men and women who have reached these ages. What have you observed in your own life with your experience as you go through this? But I guess as we look at these sort of findings, what are the next steps for this? Is this something that may be something that we can modify to help manage multiple sclerosis? And a follow-up to this, because I know from our previous conversations that this is something that we're passionate about sharing as well. What are the difficulties and challenges that you've faced in being able to take those next steps?
Right. So I think the beauty of it is that the NIH has done a great job of getting people to look at both sexes, and people are identifying these things like, menopause is probably bad, andropause could be bad. And the reason for that is because testosterone is converted to estrogen in the brain, by the way. That's why you see similarities and why the loss of both of those could be neurodegenerative. And so I think we've learned a lot. We still need to learn more, but I think the biggest challenge is we need to move this to treatments. And so you don't want to just go and figure things out and everybody writes a chapter in a book and we've learned. We want to do more than that. We want to actually help people. We want to treat things. And I will say this about aging. There are a lot of things in aging that I don't think are reversible. And that's unfortunate, but I think there are some that could be. And I think this dramatic loss of estrogen during menopause, just from very high to very low, is treatable. Now, let's talk about the treatments that have been used, not in MS, because nothing's been done for menopausal MS patients treating with an estrogen. But let's talk about what's been done in healthy women. Well, actually, the only thing that's been done is to treat them with low-hanging fruit like Premarin, which is pregnant mare urine proteins, which is a mix of a whole bunch of different estrogens, or estradiol, which binds to ER alpha, which creates adverse effects. And so I think that what we need to do is we need to take the estrogen story, as we've done for every other treatment for MS, and that is to focus on an estrogen that with the appreciation that the type of estrogen matters. We know in our trials of estriol, which is a pregnancy estrogen, it binds ER beta over ER alpha, so it has less adverse effects. It can confer some of that pregnancy of protection that, that's known during pregnancy, that women with MS are protected. We also know from estrogen's work that the dose matters, the timing matters, the compliance matters. And it's hard for me to understand why this is such a challenge, because there's great precedent in the interferon literature. The MS community has done this. They've done it with the interferons. For example, we know with the interferons, the beta interferon works, gamma interferon doesn't. We know that the dose matters. High doses work better than low doses. We know you have to be compliant, and you can't measure those by blood levels. With estrogens, you actually can. We also know that the timing matters. The interferons work better in some early patients as compared to some later patients. And so all of this can be done. It's not like it's reinventing the wheel. Then why can't we do this with the estrogens? Why can't we treat with an ER beta ligand, not an alpha, or at least estriol, not estradiol? Why can't we give it at a high dose and not a low dose? Because ER beta ligands would be safe. And why can't we, recognize that we could even get a blood level to make sure the levels are up? And we also know the timing matters. So menopausal studies in healthy women that treated with Premarin and they were 70 years old or even 50 years old, Premarin doesn't work. That would be a negative control. It's almost like the MS studies where, Avonex is often a negative control comparator in a lot of studies because it's a low dose. It doesn't work as well. It is a beta interferon, but let's face it, the dose is quite low. So this can all be done, and it just has to be done in a very standardized pharmaceutical way where you maximize the ER beta ligation and you pay attention to timing and dose.
So, sorry, can I just follow on from that? Do you, in your opinion, and this is almost an impossible question to answer, do you see that happening?
I think the challenge is for estriol has always been, and I've got UCLA has a patent for estriol, and it can't be a product patent because it's not a new drug. We know a lot about it. It's been around in Europe and Asia for years. It has a safety track record. It's not a new chemical compound that you can patent. So estriol, we have a use patent. I'm an inventor on a UCLA patent, and it's been very difficult because how much can you really charge? Not much. You can't charge $60,000 to $80,000 a year for a drug that's available in Europe and Asia and in compounding pharmacies across the United States. And so we actually are trying to think of a way to do a different strategy to bring something that can be safe and inexpensive to the market, and a way that we can collect real world experiences with estriol and MS and monitor it and develop a database and present this to the FDA to say, is there a way we can ever develop a drug that would be inexpensive and have a safety track record, as opposed to something that's patent protected and nobody knows what it would do because it's only been given to animals and a few people. So it's a challenge. It's a method of drug development on how to develop a cheap drug. How can this be done? Other than the only way we get there now is if they had a lot of money made because they were patent protected and then they went off patent after 20 years. But what about drugs that the things that come out through sex differences research won't be that way. It will be naturally occurring phenomenon with naturally known sex hormones, testosterone, estrogen, maybe a progesterone. It depends on what the data show. But how will that ever make it to phase 3 trials that cost literally millions and millions of dollars? That's the problem, a financial problem.
Well, that certainly is. And unfortunately, I know that's something that you have been working on to crack that riddle for more than a little while now. But please don't stop, because at some point we'd like to think that the best minds prevail when it comes to solving MS. And my goodness, what occurred to me as you were talking is actually not so much what's happening here in the United States necessarily, but in countries where the idea of being able to afford disease-modifying therapies puts them out of reach of everyone. It seems to me World Health Organization and its like would be totally on board with being able to find something that can help all those folks with MS who are not going to be able to get that $60,000, $80,000 a year drug. Even at the prices their country may pay, it is still out of reach for so many. I was speaking with a neurologist not too long ago from Kenya, where they have one MRI in the country. And so being diagnosed, let alone treated, is beyond the reach of so many people. So this could, in a true sense of the word, be world changing.
Yes, and I want to give credit to the Conrad Hilton Foundation, because they are as you know, a nonprofit who has tremendously donated to MS, and that's one of the reasons they have supported this estriol work all along, because they have a global view. They're Bill Gates has that. Of course, I haven't talked to the Gates Foundation, but the Conrad Hilton Foundation does have a global view of helping people, not just in Western, Europe and Canada, the United States, who have access to amazing financial, wealth, they are concerned about people in Eastern Europe, in India, in Mexico, in Africa. They're getting, they can't afford these drugs. And man, isn't it something, couldn't we develop something that could be accessible to everyone? And I will tell you, there are people even in the United States, in inner cities, as well as far, I come from a very small town in Oklahoma, and not everybody has access to these kinds of things in universities and big trials and drugs. It's just, we need to think about, other than the few people that are the haves, maybe think about the have-nots and develop something for everyone.
Any final thoughts that you'd like to share with us about your work?
Yeah, I do want to offer some more hope, and that is that another tremendously exciting area of this sex differences research, which is on that other side, which is on this females being more susceptible to the early phase with the inflammation, the new lesions, and all this. We have had very exciting data on sex differences in that, which is females 3 to 1 more susceptible, not that other phase of disability accumulation around the menopausal time, but this earlier phase. And that has come from studying sex chromosomes. So it's not all about sex hormones. Sex hormones clearly have an effect, but that's not mutually exclusive of having sex chromosome effects. And by that I mean females have 2 X's, it's XX, males have XY. And could there be a role for XX in being a bad thing with respect to susceptibility to MS, rheumatoid arthritis, and lupus? And so a tremendous amount of data is accumulating of a deleterious effect of having 2 X's. We've got a few papers published on that, and we've even identified a gene on X that can change the gene expression across the transcriptome of all genes that could be promoting neuroinflammation. And so ideally, we'd like to come up with a treatment to reverse the effects of that X chromosome gene, and you can see where that would lead. That could be very exciting for that phase of the disease.
Yeah, certainly. Look, I mean, I think I speak for both of us in saying that your work is amazing and hopefully going to make a huge difference to the lives of people living with MS. I know that people who are listening to this interview are going to be wholly supportive of your work, and I really encourage everyone who is watching or listening to this interview to support this work, because it's clear that the more people that we get behind and pushing for progress in the area, the better the outcomes will be. You've obviously got Jon and my support for this through RealTalk MS and MStranslate, and we'll do what we can to help progress this research as well. But thank you very much for your time. Thank you for taking the time out of your incredibly busy schedule to share this research with the MS community. It's much appreciated.
I want to thank you two, because you two are leaders in helping the MS community from the grassroots, the ground up, and seeing the big picture about what patients need. And so I really want to thank you too.
Well, thank you. And I thought that was wonderful. It was, just listening to you talk, Rhonda, I think that so often we think about MS research, we think about research that's designed to answer a question. And you don't have all the answers, but you've answered several questions, and we need to do something with that body of work. We have some answers. Now let's get on with it. So really.
We need treatments. We need to convert it to the clinic, bring it to patients. That's what we need to do.